Hello friends, in this tutorial we want to look at how to find the absolute error using the number of decimal places. If you haven't subscribed, I request you to subscribe to this channel so that you can be alerted whenever I post any other new clips. Now by definition, the absolute error, which we'll call AE, is given by a half of least unit of measurement. Measurement, which I'll call LUM. Now, what is the least unit of measurement? This is the smallest measurement that you can get from an instrument. For instance, if you are using a meter rule or a ruler, the smallest length that you can get from a rule is 1 millimeter, which is 0.1 centimeter. So in that case, the absolute error, that is for a meter rule or even a ruler, the absolute error will be a half of the least unit of measurement, which you said is 0.1 centimeter, and that would give you 0.05 centimeters as being the absolute error. Now, if we consider a measurement like 12.5 kilograms, and then we are asked to find the absolute error or the error in that measurement. Okay. Now, this measurement has been given to 1 decimal place, or we can say to the nearest tenth of a kilogram. So in that case, our least unit of measurement is the tenth of a kilogram. And a tenth of a kilogram, of course, you know, is 0.1 kilogram. And therefore here our absolute error becomes a half of the least unit of measurement, which in this case is 0.1 kilogram. And the absolute error is 0.05 kilogram. If we, for instance, again, we have, let's say, even 12.35 kilogram, and then we are asked to find the absolute error in this measurement. Now here we'll ask ourselves, to what what number of decimal places has this measurement been given? We can see is to 2 decimal places, which is actually to the nearest 100th of a kilogram. So in our case here, in this case, when we have 12.35, the least unit of measurement, LUM, is 0.01, a hundredth, 1 over 100 of a kilogram. And using this to get the absolute error, so the absolute error in getting a measurement of 12.35 kilogram is actually a half of the least unit of measurement, which is 0.01, and that gives you 0.005 kilograms. Okay, so we can see when we have 2 decimal places, the least unit of measurement is 0.01. When you have 1 decimal place, the least unit of measurement is 0.1. What do you think will be the least unit of measurement when you have 3 decimal places? Correct, you are right. It will be 0.0001. E.g., if we have like 12.475 kilogram, we'll have our least unit of measurement being 0.001 to the nearest 1,000th, and therefore the absolute error in this case will be a half of 0.001, which is 0.0005 kilogram, the absolute error. These are the absolute errors. Now we want to look at a shorter, what I consider a shorter way of doing this, by just getting to know the number of decimal places and you go directly to find the absolute error. Now, if you later look at these examples and many other examples that you could find, we can make a conclusion that the absolute error can be given by this formula. And this is the formula that I want us to take home. 1 over 2 times 10 power n. Where, now what is our n here? N is the number of decimal places. The number of decimal places that a measurement is given to. Okay? The number of decimal places to which a number is given. Now, for instance, we have, and remember the formula has, it's 1 over 2 times 10 power n. And the 2 times 10 power n are in the denominator. Both of them are in the denominator. So like in our case, in the first case, we had 12.5 kilogram. Now, how many decimal places do we have here? 1 decimal place. So what does that mean? Our absolute error is 1 over 2 times 10 power 1. And 2 times 10 power 1 is actually 1 over 20, which gives you 0.05. And that's what we have up there, you can see. Okay. Now, if we take the next measurement that we had, 12.35 kilogram, how do you get our absolute error? Will be, now using our formula, 1 over 2 times 10 per how many decimal places? You can see 35, 2 decimal places. So it's 1 over 2 times 10 power 2, which is 1 over 200. And this, if you work out, will give you 0.005. And that's what we also had up there, you can see. Now, if on the other hand we have, let's consider 12.75 kilogram. The other example that we had, 12.475, sorry, 12.4, sorry, let's just cancel out, 12.475. Now, what will be the absolute error in this case? AE will be 1 over 2 times 10 power, the number of decimal places. This was written to 3 decimal places, so that will be 1 over 2000, and that should give you 0.0005, and that you can confirm is what we had earlier up there. Sorry, what we had up here, you can check here. So what are we trying to say here is that if you know the number of decimal places, or by knowing the number of decimal places to which a measurement is given, then you only need to use this formula, that is 1 over 2 times 10 power n, where n is the number of decimal places. Now, what if we have a measurement like, let's say even 12, exactly 12 kilograms. Now, this has not been written to any number of decimal places, but we can still use our formula to get the absolute error. So in our case here, when it is 12 exactly, or any other measurement, exact measurement, or whole number measurement, the absolute error, we'll still be able to use our formula 1 over 2 times 10. How many decimal places? No decimal places. And how do we represent no decimal place, 0, no number of decimal places, and that becomes 1/2. So the absolute error when we have a whole number measurement, or a measurement given as a whole number, the absolute error is 0.5. So in this case, it will be 0.5 kilogram. So that formula applies to all cases from 0 number of decimal places to infinity. Hope that was helpful to you. Please give me a like and share with your friends. Bye bye. If you have any questions, you can go to the comment section and post them, and we would be very glad to respond to them. Bye bye and stay safe.